Folks, good afternoon.
Today's speaker is Garry Kozak. Garry is the CCOM Sonar specialist for Klein Associates. He also is the president of GK Consulting. He's involved with undersea search operations, consulting, and training using CCOM Sonar systems. And today he's going to talk a little bit about undersea discoveries using CCOM Sonar.
Good afternoon. First, I'd like to thank CCOM for inviting me to speak here. It's actually probably in some ways more fun for me than for you because I get to relive some of the past missions and things that I've been involved with. And so starting out, of course, with a great slide, which is neither a sunset or a sunrise, but it sort of makes you appreciate what a lot of us are involved with when we go to sea to search or survey or map the ocean floor. And of course,
side scan on that deck?
there is a side scan on that deck.
On the deck.
Yeah. On the deck, yeah. Not in the water. No. So we're dealing with sonars, and of course, all of us have probably a basic understanding of sonars in one sense or another, and we can clearly relate to things like bats that use sonar to range and locate, or dolphins and porpoises, or submarines, which have been using this technique forever. And of course, what's unique about side scan sonar is that we refine it such that we can create not only ranges to a target, but also imagery of the seafloor. So, and conceptually, the way this is done is, actually, let me jump here to this slide.
Cutting off the bottom of the screen.
Yeah, Gary, I'd like the whole picture.
Yeah, something's haywire here.
That's a good question. I
That's
don't
an
know.
excellent question. Sure. Our viewers on Google Meet.
Well, there's one way we can do this. Let's cheat. Let's resize this so it meets what that is.
It looks like it's not projecting on the whole screen.
Yeah.
I mean, it's like the projector is occluded in some
May
Why
have
don't
something
we,
to do with
the
the VGA connection to this particular laptop.
There.
That'll work, huh?
Yeah, that'll work.
Yeah.
Okay, so it's just a workaround quickly, get it so it meets the screen requirements. Okay, so sonar systems that we deal with, all of them have four basic parts to them, whether it's an echo sounder or a side scan sonar. And the four parts that we're dealing with is we need some kind of element to actually create the sound to ping in the water. And we use the same element to transmit and receive, though some sonars use separate elements. So, but their main function is, one, we need an element to transmit the acoustic ping in the water. That ping travels out. When it hits some kind of boundary, we'll get some energy reflected back. We receive it, goes into a receiver, we amplify it, and then we feed it into a display so we can look at it and make some sense of it. And of course, the simplest sonar is an echo sounder, where we're measuring water depth. But in our case, we're measuring ranges not down to the seafloor, but off to the side, because we want to know where a feature or an object is on the seafloor looking out on each side of the vessel. We want to go one step further and actually create an image. So what we need to do is to, well, unfortunately, I can see what's going to happen with the screen resizer, because of that, it's not going to work so good. So we may have to suffer through with some of it cut off.
Can you toggle through maybe some of the video modes real quick? That won't affect the broadcast.
Okay,
But
let's,
we'll just end up seeing something different on the screen.
Let's try that one. Except I have nothing here. Let me toggle one more time and see if I can get it back where I can see here. Otherwise, I'll have to drive it up there. Let's try one more. Technology is great when it all works perfectly.
Oh, wait, it comes.
Hey, all right.
Yeah.
Nice job.
We
Ron.
good?
Yeah.
Okay. So with side scan sonar, we've still got those basic parts as all simple sonars, but the one thing that we really focus in on to allow us to make an image of the seafloor is that the transmitting elements are designed such that the sound just isn't projected in all directions. We essentially make a transducer array that will, conceptually, you can think of it as focusing. We make a beam that is very narrow in the horizontal plane, but wide in the vertical. And the whole purpose of trying to create a narrow beam is we want to do an acoustic technique called line scan. In other words, as the sonar is being pulled on a cable behind the boat, this narrow beam, every time it transmits, it only looks at a strip of the seafloor per transmission. It moves a little bit, it goes to the next strip, and only receives the information in that strip, and then to the next. And so conceptually what it is doing is it's slicing the seafloor acoustically into strips, one by one by one, and we map those strips in order to create an image. An analogy would be taking a photograph with a pair of scissors, cutting it up into slices, and then you take those slices of the picture back together in order with Scotch tape, you got the picture back. So that's all we're doing acoustically. We're designing that sonar so the beam is very narrow as it's moving, it's slicing the seafloor in strips. We map those strips in order and you got an image. And of course, the narrower slice that you can make, the higher the resolution. So now we've got a sonar that will actually create images of the seafloor. And here's a little diagram sort of illustrating that concept where the towfish is moving behind the vessel. And when we ping at position 1, we only get echoes off that part and that part of the wreck. We map them on our display. Position 2, so on and so on. So we're slicing it and mapping those slices in order. And we create a acoustic image of the seafloor. And of course, these images are really pretty incredible today. The resolution we achieve is phenomenal. It's almost approaching optical. You take a look at this portion of the seafloor that is geology. You're looking at small sand waves. You're looking at rock outcroppings that you can see the jointing and cracks. I mean, literally, if you remove the water and look down on this, it would look exactly like what you're viewing right now acoustically. So you can see if you have a little bit of the Indiana Jones in you, and you like discovering things, you can see the possibilities. And I mean, that's truly what got me in the business back in the 70s. The first time I saw this sonar make a picture of a shipwreck, it was better than Playboy. I mean, that's the only analogy I could give you. This was a system that really just, it blew me away conceptually that sound could give you this kind of picture on the seafloor. And of course, your mind starts running wild on possibilities of how to use this stuff. Now, I know, like here at UNH, a lot of the people are involved in bathymetry and mapping geologic features. That's cool, but I mean, the really thrilling part is seeing a man-made object like a shipwreck or an aircraft or a lost city on the bottom. Those things are really, to me, even far more exciting. The technology is not new. I mean, it is over 50 years old. First started in the 50s by the US Navy, and then in the early 60s, the commercial community started building products for survey. And here's an early Navy side scan from the 1950s. And the towfish were large that we towed back then, and these were operated at very high frequencies. And the one thing I'm not going to get into is turn this into a design system. I'm trying to show you some of the fun parts of this thing. But the one thing you need to know about sonars is there's always this trade-off that we're looking for. We want range, where we can see far, but of course we want resolution, detail in what we're looking at. Unfortunately, the physics don't let the two go together. You've got long-range sonars, but at the sacrifice of resolution. And if you want high resolution, you've got to use high frequencies, but at the sacrifice of range. So we're always struggling and balancing the design of sonars for the mission application. If you're out looking for the Titanic, you use one type of sonar. If you're out looking for a mine or a cannon, you use a different kind of sonar. And so we don't have one that'll do it all. These systems were very high frequency because they were interested in mines, bombs, that type of thing, and they needed resolution. Of course, the beginning of commercial size scans, as most of us use today, actually began here in Boston. And for those that are old enough, you recognize some of these characters in this photograph. Those that are younger probably don't recognize any of them. But let me tell you who they are. This guy here is Jacques Cousteau, who's one of the most famous oceanographers in the world. And on the very right is a guy named Harold Edgerton, who is famous in his own right as a scientist and engineer who taught at MIT in Boston and started a company called EG&G in Boston. And some of his accomplishments are pretty incredible, all on their own. Edgerton was known as Papa Flash. He is the guy that invented the electronic strobe that we all use on our cameras. And even more importantly, during World War II, Edgerton was given the task of coming up with a photographic technique to capture the first atomic bomb blast test. And you can imagine back in the 40s, trying to come up with a scheme to image an atomic bomb exploding, how fast it is. Well, Edgerton designed a camera called a Rapitronic. It was a one-shot camera, and every image of the atomic bomb blasts that were taken back in the 40s were done with an EG&G Edgerton Rapitronic camera. But Edgerton, besides doing all this cool stuff with high-speed photography and development of the A-bomb, he loved the ocean. And he started a division there to develop products for searching and surveying and so on. And one of his students, by the way, if any of you are in Boston, I recommend two things to you if you've never done this. And you know, for as long as I lived in New Hampshire, I only did this a couple of years ago, and I was surprised I didn't do it much sooner. Two things you want to do. One is go to MIT, and they have a museum. It's an incredible museum with all the technology and things that have been developed at MIT. And the other thing is to visit the Edgerton Wing at MIT, which is, you can find it on the website, Edgerton Center. So if you're sometimes cruising around in Boston, you should take in these two places. They're really interesting things on what has been developed in this area. But anyways, back to Edgerton. He had a student at MIT, a guy named Martin Klein. And Martin Klein was in electronic engineering. And when he graduated at MIT, Edgerton hired him to work on a new commercial product, side scan sonar. So it is really where I consider the birth of commercial side scan systems. It was in Boston with this guy Edgerton and Klein. And this is Marty Klein with one of the very first development systems back in the 60s. Of course, the technology has changed dramatically. You really don't appreciate the equipment today unless you worked with some of it 20 years ago, 30 years ago. And the number of knobs and controls and things we had to do. But of course today we've all merged into the computer world. And everything is done for us with computers and software, and it's simplified enormously compared to the way we dealt with it 30 years ago. But the real fun is putting one of these sonar towfish in the water and towing it around, and the discoveries you'll make, whether you're a geologist looking at geologic features, or if you're somebody that is an Indiana Jones type of person that wants to find that holy grail that's been lost. And I'm sort of fall into that category. That's what got me interested in this line of work. And you can see from the imagery why it's so exciting. When you see a two-masted sailing vessel that looks like you could literally put up the mast and sail that guy away today. I mean, I look at this, and as long as I've been doing this, I go, wow, that's still really cool. The fact that you create those images with sound. So here's a two-masted sailing vessel in the Great Lakes. Right out off here, off Boston, there's a very famous steamer called the Portland. Sank in the Portland gale back in the late 1800s, loss of all lives. Searched forever until found by NOAA a few years back. And there's a great image of the Portland shipwreck sitting out here on the Stellwagen bank. And you can see clearly the boiler section, where the boiler smokestacks came up. You can tell a lot about this. I'm not going to get into interpretation, but you can see the back hull part. As a matter of fact, right here, if you can see this sort of a veil, that is a fishnet that is snagged on the wreck and floating up above, casting a weak veil-like shadow. So for those of us that are gonna work around a structure, the sonar is incredible because it tells us, it gives us a roadmap of everything that's on the seafloor. And if you are running an ROV or a diving operation, the first thing you want to do before you put anything down is image it to know exactly what you're going to run into before you actually begin work on a site.
Gary, what's that zigzag line going off in?
This is a drag mark. Trawl marks from fishermen that have trawled all around this wreck and across it. It's one of the interesting controversies that today you've got sort of two communities that deal with underwater wreck sites. The archaeologist and the salvor treasure hunter guy. They're very opposed to each other, but one of the things the archaeologists like to propose is that wrecks should be left in situ, that the best preservation is to leave them on the seafloor. The fact is, when you really map the seafloor, you realize how bad trawlers are tearing up the terrain, and almost every wreck that is there has been hit by trawlers, or tore up or destroyed, and that over time these wrecks are going to nothing. So I don't necessarily agree with the archaeological attitude that you leave it on the seafloor. I think grab it while you can, because in another 1,000 years it won't be anything. But that's open to discussion. Of course, other things that are lost in the ocean besides ships, amazingly, things that fly. And again, seeing a image made with a sonar of an airplane sitting on the seafloor is pretty darn exciting. I'm sure not for that pilot, but for those of us that find these objects, it's really sort of cool. So you can see the possibilities with these sonars. And of course, for search and recovery teams, the fire and police departments that have to go and do the grim task of finding a drowning victim. I mean, it's one of the biggest applications today for this technology is locating drowning victims on the seafloor. And it's amazing how many people drown every day in the world. As a matter of fact, I want to recommend something to you for those of you that don't know. If there's a topic you're interested in, whether it's drownings or treasure or sonar or geology, if you are not familiar with Google Alerts, get familiar with it. Go in, and Google supplies a little utility that you can put in any keyword you're interested in, and once a day you will get a download of all the news in the world on that topic. So if you want to be an expert in something, get Google Alerts, put in your topic, and every day you'll be able to read what's going on in the world in the news. It's invaluable. That's got nothing to do with sonar, but it's a good tip. So, we work on different kinds of platforms with these sonars. We've worked out of helicopters, and of course we've worked out of small submersibles like the Alvin. And of course, one of the big applications for sonars, putting them on the nuclear subs that go under the Arctic, and they do a little something different. They don't look at the seafloor, they turn these up and they look at the ice. And they map the underside of the ice. It's very valuable information for the people that are driving these submarines under the Arctic. Of course, the really new technology that has really come of age today, autonomous underwater vehicles, free swimming programmed robots. You put the sensors on board, you tell them to go in and do a certain function, and they go off and actually do it and come home. And these are being used a lot commercially for everything from oil pipeline surveys, fiber optic cable route surveys, in this case, Spanish galleon treasure hunting. So even the high-tech treasure hunters will buy AUVs to look for things. And the beauty is that you can work in very deep water and you don't have to deal with large ships and large cables, and it just makes things far more compact. And the bottom line is the quality of the data that's recovered off an AUV is the absolute best you can get in the world. Of course, occasionally the AUVs have a visitor that likes to sort of, I think this is sort of, whose ocean is this really? But here's the kind of product that you can get out of these AUVs. This is a large-scale ocean mosaic. How big is it? 1,800 square miles. You've got to appreciate the size of this. And these are many days of AUV missions collecting and mosaicing all this data, but you see one thing right off the bat. Look how perfect it is. Every survey line is absolutely precise. The spacing, positioning, precise. So precise that we can go in with cameras and do video or photographic mosaics where we're dealing with tiles that are only 2 or 3 meters by 2 or 3 meters to tile a complete area. And occasionally you find some bizarre things that excite geologists. It's the Spanish galleon that gets me excited, but you notice that little bright spot right there? That's a very unusual feature. This is over a half a mile of water depth, and it's a crater like you can't believe. It's 250 meters in diameter, all by itself, one single crater on the seafloor. That's something for you, Jim, to explain to me what made it.
But where is it from?
It's out on, it's north of the Bahamas.
Yeah, they're blue holes, they're called.
Yeah, but it's the only one in the area. And it's way out. It's 100 miles north of the Bahamas, 150 miles north.
Yeah, they're common in the Cretaceous carbonate stuff there.
But you'll notice in that 1,800 square miles, that's the only one.
Yeah, that's the only one you found.
Well, it's the only one in the 1,800 square miles. I'll tell you that right now.
Yeah.
So you will find these really intriguing features, and this has happened. I've got a lot of examples of this around the world where we've gotten geological structure that is hard to fully explain without a lot more research being done. And as I said, these AUVs are incredibly capable of doing high precision photographic mosaics a half a mile down automatically. And this is an old British shipwreck, we suspect, and it is at full resolution. And you can see this is, I forget how many photographs it's made up of, but it's about probably 120 photos. And let's see if we can just zoom in quickly here to show you the detail and the precision we get out of an AUV with a photographic package on board. I think it's running a little slower because of the software, because yours loads quicker. I probably won't zoom in any more than this. And just let it complete loading. There we go. So we'll just take a look at a couple quick areas, like over here. The anchor's on this old shipwreck, half a mile down. And we'll sort of shoot over to the cannon that's on board. There's a cannon that is located right there. Can you see the outline of the cannon? And if you come over to the end of the wreck, you'll see the bottles, the rum bottles, I'm sure. They had to be rum bottles that the sailors had on board this shipwreck. So you can really see the possibilities with the latest AUV, sonar, camera technology, payloads that go on these to look at objects down in very deep water. But of course, some of the discoveries that have been made, and we got to start with the biggest discovery ever, the Titanic. I mean, it's the first thing that comes to mind when somebody thinks about a shipwreck in the ocean. It's the Titanic of shipwrecks. Is that a pun? And of course, side scan was one of the elements used to locate this. Bob Ballard, with his what was called the Argo tow sled, had on board a side scan sonar, and it was instrumental in the locating of the Titanic. And for those of you that don't know, there are actually two groups involved in searching for the Titanic. It was not just the Americans. The French teamed up with the U.S. and they jointly did it. It was in the area of the American search, not in the area of the French search, but really recognition has to go to both countries because they both were out there searching for the Titanic at the same time. Of course, we hear very little about the French involvement at all, which really sort of irks them, since they invested a lot of time doing the survey work as well. But that's sort of how the cards fall. And of course, back then, the sonars used paper recorders, not computers like we're using today. And the image of the Titanic was not terrific back then, for a lot of reasons. That tow sled that Woods Hole built was not very stable, and it's tended to distort the imagery. But nonetheless, it was sufficient to locate the Titanic, and of course, the rest is history. We've been probably Titanic to death because we've heard so much out of the Titanic over the years, and it's still ongoing. But nonetheless, it's an incredible find, and some of those images made by National Geographic, Woods Hole, they're classic, the bow of the Titanic. And I see Leonardo DiCaprio standing up here somewhere, singing or something, I don't know. But of course, there's a lot of other fun places, and one of the early things I got involved in back in the 70s when I started working at Klein Associates was with a group called the Academy of Applied Sciences. They're a group of scientists and engineers out of Boston that were trying to prove or disprove Loch Ness, the myth of Loch Ness. And of course, if you've never been to Loch Ness, whether there's a monster or not, it's irrelevant. It's an incredible place to go visit. It just is majestic. And looking down the loch here from Urquhart Castle, it's really nice. And of course, the famous photos of Nessie, and is there a monster? And so again, you had this clan, the Academy of Applied Sciences, and the only one that wasn't really a scientist was me. But you had Doc Edgerton, you had Dr. Rhines, who was the leader of the group, Marty Klein. One or two of these guys was from Polaroid Engineers, and what they did is they designed cameras with Edgerton strobes, and they had sonars on board, and they would moor this mid-water, the sonar pinging, and if an object swam through the sonar beam and got an echo, it would trip the strobe and capture whatever was in the water. And so their whole concept was to try and snap a picture of Nessie swimming by one of these station cameras that was hung around Loch Ness. And did they get a picture? Yeah, they got something that was thought to be a flipper on a plesiosaurus. And for years, that's what they, sort of the going theory was, that one of these swam through and they captured the picture to prove that the Loch Ness monster exists. So we got involved in doing a lot of side scan work and mapping the loch, trying to find the monster. And Edgerton and Klein, again, were key components in this Academy of Applied Sciences. And of course, they would found unusual features. They found these circular features on the bottom of Loch Ness. Could not really define what they were. They thought they were some of the remnants of these age-old stone circles you'll find in England and Scotland. I can't get into the long story, but it turned out they were dredge dumpings. But there is a funny story about Marty Klein and Klein Hedge, which I won't elaborate on, but it got a little out of hand when they first thought they were these old stone circle sites. But we did a lot of exploration, and that was some of the early days of diving. I had fun. I mean, I used to dive on a lot of the stuff I used to do back then, because my real career began in the diving industry before I got into side scan. So I would always look for an excuse to get in the water and go exploring. And of course, Loch Ness was one of those places. And we did find some interesting historical things. One of them being this World War II plane that was long forgotten after World War II. And this plane was recovered and is now totally rebuilt and in a museum in England somewhere. I forget exactly where it is, but it is now in a museum. So, some interesting outfall. I've been back to the Loch Ness quite a few times because I just find it a neat place to go. It's got some of the best sub-bottom geology if you're a geologist. We did do one unique thing, and that is we made a single long-range complete map of 21-mile-long Loch Ness. And this is the sonar mosaic of the entire length of Loch Ness compared to an old 1906 lead line chart that is in a museum over there. And when you zoom in on this 21-mile sonar map of Loch Ness, a couple of interesting things. First, you'll see right off the bat that the basic bottom of Loch Ness is nothing but a flat mud plain. Secondly, you've got some great plume areas where the creeks and rivers flow down into the loch with sediment and leave these plume areas down the sides. But more interestingly, there is one feature we have not explained today, though we've looked at these. It's the Nessie Trail. We've got running around the loch in certain areas these circular features that we can't explain what made them. And they will run sometimes across the loch, down the length of the loch like this. There'll be different sizes, but the average is about 15 meters in diameter. We've run sub-bottom profilers over them. Can't delineate them with the sub-bottom. So we really don't know what they are and what made them. So we still have an excuse to go back. And we will at some point. Is there a Nessie? No. Take it from me. There is not a Nessie. Though the Scots can't let that out because the tourism, their whole economic being would fall apart in Scotland without Loch Ness, because the amount of tourists that go there every year is incredible. We're going to jump from Scotland now to the Arctic, to another incredible discovery that was done. Some of you from your history may know a name called Franklin. Franklin was the guy that tried to find the Northwest Passage through the Arctic for the shortest route to the Orient. And Franklin and his two ships, the Erebus and Terror, disappeared. Never found. To this day, still not found. But when they disappeared, the British Navy sent out the longest search ever, 10 years, trying to find the Erebus and Terror and their crews. And during that search, one ship was sunk in the Arctic called the Breadalbane. And there was a diving doctor called Joe McGuinness that was on sabbatical at the Scott Polar Research Institute in the UK, and he found out about the Breadalbane, so he put together a project with National Geographic to try and find this ship that was in the hunt for the Franklin expedition. And of course, there are old historical paintings showing the Breadalbane being caught on the ice, crushed, the crew getting off, the ship sinking. And McGuinness pulled together with funding from National Geographic to go up there and search for this wreck. Well, let's say it's not quite the kind of area you want to run a tow sauce in, and you'll see why in a minute. You can see where it's located. It's way up in the Arctic. And one of the interesting things is not only the purpose of the mission to find a historic shipwreck or a lost airplane. A lot of times the fun for me is the characters involved, the personalities, the people you meet on these expeditions are so different, totally. And this was an interesting one for me, dealing with a guy named Emery Christoph and Joe McGuinness. These guys are smooth, I mean, really smooth. I learned a lot from them. So we pulled into this last outpost called Resolute Bay, and we've got a whole team up there. We've got National Geographic photographers, we've got all the scientific people, we've got me with a sonar, and we're supposed to have access to an ocean oil exploration ship that's transiting the Northwest Passage to the Northwest Canadian oil fields. And they said we could have a week of survey time on their ship. If we got the Resolute, load, go and do the search, and then they're going to continue. Well, we get all up there at the Resolute, and the weather is so bad and so cold, and the ice is moving in so fast, the survey ship says, we can't stop. We stop, we're going to get iced in and never make it. So everybody is sitting up here now with no ship in the bar drinking, saying, licking their wounds that were going home and didn't even get on the water. And a couple of helicopter pilots come in, and McGuinness and Christoph look at these guys, say, where are you from? Oh, we're from a Canadian Coast Guard icebreaker, sitting right off Resolute right now. Really? Would you fly us back out to the ship so we can talk to your captain? And so the chopper guy said, sure, we'll fly out. And then my learning of how to manipulate people began. I'm watching Christoph and McGuinness talking to the captain, explaining how they want to borrow his icebreaker for a week to go look for a shipwreck. And I said, this is never gonna happen. And the funny thing was, McGinnis was a very good friend of, at that time, the Premier of Canada, Pierre Trudeau. And the captain says, if you can get the Canadian Coast Guard to authorize it, you can have the ship. McGinnis calls Pierre Trudeau, Trudeau calls the Coast Guard gives him the ship. So off we go to do this search up in the Arctic. I'm going, these guys are smooth. Except, it's gonna be a little hard to tell with the side scan this. As I'm looking at this, this is like mission impossible. And explaining to the captain, okay, we're gonna try this. We're gonna try and put this fish through the little moon pool behind the boat and tow it and see if we can find this wreck. And you've got to give me E for effort.
Must not have been your side.
It wasn't my side. That was the point. But the bottom line was, when we first finally got some imagery of the seafloor, it was filled with these huge iceberg scours. And we said, this ship is never going to be intact. It's going to be toothpicks. And the first year there, we could not successfully find anything. So we went back a second year. Canadian Coast Guard again, another ship. And this is sometimes the strange part about doing searches, the element of luck that comes into it. You plan, you do all your research, you come up with the best scenario, and you come up with an area you say it's in. And this is truly how this happened. I'm not making this up. We get everything all set up. We're going to start survey operations next day to search the area. It's about 10 o'clock at night, and I said, look, let's throw the sonar in the water for 1 hour just to test it. We'll test the navigation gear. We'll just make sure everything is clicking so when we get up in the morning, we can start work with no problems. So everybody says, okay, so we throw the fish in the water. We are a half a mile outside of the survey block. Half a mile, not even in it. Throw the fish in the water, and we're just towing along, making sure everything is working. And Joe McGinnis is standing behind me and says, what's this thing gonna look like when it comes out on the paper? And I'm saying, well, it's gonna look probably like a bunch of toothpicks and the paper's rolling out. And I go, it's gonna look just like that. And it scrolled right out at that instant. And I look back that if we would not have done that test that night, we would have gone to the survey area that they researched, run it all, and never found it. So a lot of these searches have, I hate to say it, an element of luck at times in it. So the imagery was incredible. Here is this 1800s British ship that we thought was going to be toothpicks, sitting intact with two masts standing on the seafloor.
What depth of water is that?
345 feet, 110 meters. And so we needed to get images of this. So we had archaic cameras, drop cameras, nothing smart, no video. So Emery-Kristoff programmed a camera that was auto running every, 10 seconds, click, 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 click. And the goal was drop this down, hopefully get some images of this wreck. He needed those to get funding to go to the next stage, to dive. So we're dropping this camera down on this wreck, hoping we could get some pictures of it. We had no clue, because this was filmed, these weren't digital, so we had to wait till we got back down into the lower 48 to develop this film and find out if we captured images. So it was blind. You drop this thing down, you hope you got some pictures, and you got to get out of there. So we're sitting in that same bar again, and the next commercial flight was 3 days out, and in walk a couple of Canadian Air Force pilots into the bar, and McGinnis and Kristoff look over at him. It's like, can we buy you a drink? Where are you flying to? Calgary. You think we can get a ride with you tomorrow morning? Sure. Back up all your stuff. We'll take you down to Calgary. So that's what we did. We loaded it all in this Canadian Air Force plane, and off we go. And of course, after this kind of mission, everybody has their own way of dealing with distressing, because I mean, clearly you get sort of hyped up on one of these missions. You're going long hours, and you're hyped, and everything's on. So Kristoff sleeps. McGinnis, who is a writer, who is he keeps a journal on everything that's going on, so he can write. He's updating his journal. Some of us prefer to get into more intellectual reading, like myself. So I immediately the reading that I relate to. So we get back and we get this film developed, and sure enough, the first 150 frames, 200 frames, 0. And then we had the frames. And those frames were now the ammunition to give funding to go to the next step. To put a manned 1 atmospheric diving suit onto the wreck, to recover the wheel off it, which is now in a museum in Ottawa, Canada. And of course, it makes the cover of National Geographic magazine. So here it was an incredibly successful mission that of discovery of this old historic British shipwreck involved in the Franklin search. Now we got to jump down to Uruguay, to World War II, and a German battleship called the Graf Spee. It was cornered into Montevideo Harbor, and a lot of history on this wreck. They could not leave because the British were offshore, and the captain did not want to surrender. So he had all his crew surrender. He took the ship out, scuttled it, went back into his hotel in Montevideo, and committed suicide. And so the Discovery Channel wanted to do a documentary on this shipwreck, and of course they wanted imagery of it with a sonar. And so the ship was imaged, and this documentary is still around today. And some of the artifacts that were recovered, this bronze, German swastika, which actually became a big controversial thing down in Uruguay when they pulled this off the wreck. But it was an interesting project, but one that was just a few miles away from this, I found even more interesting. On the side scan record, what looks like a pile of rocks, boulders, actually turns out it's a old Spanish naval vessel. And if anybody ever envisions a treasure wreck, this is what I envision it looks like when you go diving. You see a wreck, of course, with cannons. And you see the coins, the treasure. And you take a look at the glasswares. I mean, it looks like this is a wine glass you could pick up today and fill up and drink out of it, still intact on the bottom. But of course, the navigation instruments and the crew scattered around. This one with the cutlass still by his side. And truly what you would think of for a pirate or a treasure ship. Skulls and crossbones and treasure and cannons. And it's amazing about preservation. We look at old shipwrecks. How diverse and different every wreck is in every location in the world. I mean, you go to some places and they're totally destroyed. There's nothing left. And yet you go to a place like this down off Uruguay, warm water, you would think most of the stuff would be gone. But not. And then you go some places that have other types of dynamics and it is gone. And so there is, in my mind, there is no rule. You can't generalize when you find an old historic site exactly what will be left and not left because of deterioration due to the elements and so on. Of course, right out here off Portsmouth, New Hampshire, World War II. We've got a pretty famous historic site out there. Submarine called the 09. It was a World War I submarine refitted for training during World War II. After the refit, the final test dives for certification were done right out here off Portsmouth. Made a dive, never came up. And the Navy looked for it, but never found it. So a few years back, there was a historian, a guy named Glenn Ream, who was a member of what's called the Boston Sea Rovers, a dive club. He approached me and he said, "You do a lot of testing out there. How about running out a little further and doing a little more testing, seeing if you can find this World War II submarine?" So I spent a few days on different testing scenarios out there, and it was really, I had given up. I'd covered the whole area he had given me again. It's one of those parts where luck comes in. Whole area covered, one last trip out, okay, we'll run south of the area a bit, and the weather was getting bad, so we'll run one north of the area, and the one running in north, the last line, give up. we get the image on long range of this target. That turned out to be the 09, and of course the 09 then led into a documentary on Discovery with NOAA and University of Connecticut, who brought their research vessel up with an ROV. They during this, it was part of, if anybody has ever seen a dive series that was on a couple of years back called the Deep Sea Detectives, yeah, with a guy named John Chatterton and get the other guy, I just went funny, but Richie Kohler. And so they were all involved in sending down the ROV and imaging the remains of the 09. It turned out that the aft part of the 09 had completely collapsed under pressure. The forward part was all intact. Something happened where a bulkhead must have failed, and the whole back of the submarine was like a sardine can, just crushed, flat. So whatever happened, happened quick. And these are some of the underwater images off the 09, 25 miles out of Portsmouth.
How deep was the water?
It's about 425 feet to the bottom. And the last thing I'll share with you is just one last story. We got 10 minutes left, and this is one of those adventures for me that started out like this is some guy's wild dream, because one thing you do meet in this business of undersea search is people who have big dreams but not the pocketbook to fund the dream. It's really common. I mean, I get people calling me up all the time. I want to go find this shipwreck. I want to find this airplane. And you go, okay. And they tell you where it is, and you go, well, it's probably going to cost this much to just begin, and that's the last you ever hear of them. So they never call you back. So I had one of those calls come into me at one time. This guy calls me up and says, I want to go look for this airplane. And he says, it's in Alaska, and would you go up and do it? And I go, okay. And I said, let me work out some numbers, what it's going to cost to go up there and actually run a search. So I called him up and I said, look, it's going to cost you this much to begin. And I need money up front because this is a lot of stuff going out for airplane tickets, crew, mobilization, parts, da-da-da-da-da-da-da. Famous line, click, hangs up. I figured never hear from him again. Next morning, FedEx arrives, cashier's check in the mail. $25,000. Yeah, he's serious. Should I go to Tahiti or Alaska? I wasn't sure right there, looking at that check. So the search begins, and as I delve into it, the history comes into it, and of course, who this guy is. It turns out this guy is an incredibly wealthy guy who made $500 million on a business. He sold it and became an airplane collector. And this particular airplane was one of 23 ever built, and the only one in existence that's intact fully. It's called an S-39. It was built by Sikorsky, and most of us, when we hear Sikorsky, we think of helicopters, but before Sikorsky designed helicopters, he built fixed-winged aircraft. And if those of you that can remember the company called Pan Am, who went under, used to be on my favorite airlines back in the 80s. I used to always fly Pan Am. Pan Am was built on the Sikorsky S-42. The S-42 from Sikorsky is what opened up the Pacific and Atlantic routes for Pan Am back in the 30s. Sikorsky built a small one called the S-39. He thought it was going to be sort of the Learjet of the day for the business owner, but they never sold because they were expensive, and there weren't that many wealthy millionaires that wanted their own private plane. But a few were built, and this one was lost in Alaska. This is the most famous one, called the Spirit of Africa. It was run by a couple of explorers. So anyways, in the early 50s, one of these S-39s, one of the few remaining ones, sank in a lake. This owner accidentally crashed the plane, flipped over, sank, and was in a remote location. Here's Anchorage, Alaska, and you have to fly across what's called the Alaskan Range to get to this lake called Two Lakes. And so you can see the problems of the logistics in just getting in there to do a sonar search to look for this airplane. So it starts, and the logistics really turn out to be the biggest part of this. Finding how to get there. You've got to bring in every piece of equipment and every spare part you can imagine, because if anything breaks when you're there, you can't run down to Home Depot. There is no place to get parts. So you've got to be totally self-sufficient. And there were a couple funny moments here. I needed a colleague of mine to drive the boat while I did the sonar aspect of the search. So I called up an old friend of mine. His name is Ralph Wilbanks. He actually does a lot of work for a guy called Clive Cussler. He found the Hunley submarine off of Charleston. So I call up Ralph. He lives down in Charleston, South Carolina. And I go way back and I say, Ralph, I got a job. Would you come up to Alaska with me, be my boatman, run the boat while I do the sonar stuff? And he says, you know, I hate cold weather, and I really hate small planes. I said, don't worry, Ralph, it's okay. Come on up. So he agrees to come up. So we meet up in Anchorage, and I'm leasing a Zodiac inflatable, because everything's got to go in by push plane. So I go to this rental place, and I get a Zodiac and an engine, and all the hardware we need and stuff, and the owner of the store comes out, and he says, where are you guys going? We're going to Two Lakes. We're going to Two Lakes. You guys got a gun? Gun? What do we need a gun for? He shakes his head and he walks back into his building. And I could just see what's going through his head. Lower 48 guys come up here to Alaska, going out into the outback, and they don't have a gun. So he walks out with a shotgun and a box of shells and these two big cans. It looks like this stuff right here. And he says, you guys are going to need this where you're going. And he goes on to tell us that it's full of bears, grizzly bears, and Two Lakes is notorious. They're everywhere. So he says, do you know how to use a gun? And Ralph says, yeah, I know how to sort of use a gun. So the guy gives him a quick lesson on the gun. And he says, these are bear mace. He says, make sure you point at the bear, not at your face when you press this to blind the bear when he's attacking you. So we go through that routine and off we go. And of course, getting to Two Lakes is sort of an incredible adventure through a pass called Merrill Pass. And as you fly through it, you look down and there's airplane wrecks everywhere in this pass. And the pilot's telling me, he says, yeah, this is the worst pass in Alaska, because once you enter, if you make the decision to go and you run into low ceiling, there's not enough room to turn 180 around. And those that try end up in the side of the mountain. So there's 23 plane wrecks scattered through this pass. So pretty exciting fly through. So we land at Two Lakes, and of course, as soon as you get on the beach and look down, you understand why the guy wanted you to have a gun. And sure enough, there were bears. Like I remember we were staying in one of the only hunter cabins that was on the lake. And I remember waking up one morning, 6 o'clock, and there's this bear standing at the glass window looking in at me. And I'm just glad he didn't realize that that glass was only one swipe away from getting me. So there's a survey boat, a little different than some of the big ones. A lot of crap in it. And the interesting thing about this particular mission was that this search had been done by side scan twice before by a couple of commercial companies. Neither could find this airplane. And this was sort of a last shot to see if it could be found. Go in, and I got to be honest. The first thing I asked the customer, do you have the data from the other two companies? He says, yes, I do. He ships me a box of these rolls of paper, and I go through them all. And sure enough, I find a contact in those rolls. Positioning was no good. They didn't have good positioning. But here's this contact at the end of this geological feature that looked just really suspicious to me. And I said, if I can find that geological feature, follow it to the end. That's probably it. That's exactly what I did. I get on site, go out, run all over the lake, find that feature, go to the end, there's the target. Zoom in on resolution. Didn't look like a plane, but it looked suspicious enough that I said, really high probability. So we went out and we grappled into it, dropped a camera down, and sure enough, it was the plane. And to say that the customer was ecstatic, celebration was in order, and though they have big mosquitoes in Alaska, he was not going to be detoured from celebrating in any way, so he found his way of doing it. Well, very quickly this project grew, and this is a whole story in itself, so you're going to get the 4-minute version here. He wanted to get this plane badly, and so that summer we put together another expedition to go in, dive it, assess the condition, and to see if there was a way we could extract the plane out of the bottom. So we went back in, got some commercial divers. This was 200 feet of water that we're diving. And the bottom line is, when we looked at it, we realized it's embedded in the sediment, very bad. We can't just hook into this thing and pull it out. We've got to excavate it. If there's any hope of getting this out of the bottom, it's got to be excavated. And the problem with 2 lakes is that you can't get big boats in there. You have inflatable Zodiacs, small John boats. That was it. Everything came in by push plane. And so we needed a solid platform we could work on. So we came up with the plan. Of course, this was in a bar again. These plans that are generated in bars. Let's go into wintertime. We've got ice, solid platform. We can work on the ice. We're not hindered by anything, and we'll do it. So the client bought into it, and we did it. So off we go. And again, a lot of problems in organizing this kind of thing on the ice in the wintertime. Flying planes that actually fly in Alaska in the wintertime is not easy. A lot of these planes shut down during the wintertime. So we had to charter a little fleet of aircraft to get in there. But I've got to say, it's extraordinary. Flying in Alaska in the wintertime through these passes, it's better than National Geographic magazine. And of course, it looked like a little airport on the ice there, with planes flying in and out, dropping off equipment, crew. And we're using another kind of sonar now called a sector scan sonar. It's just like a side scan sonar, but it's stationary. It's like a radar. This is going to be our eyes to tell us everything that's being done on the bottom. And the plan was simple. We're going to go in, we're going to hook a lift cable up to the plane, which is upside down. We're going to go in with a dredge and try to dredge the material off the wings. We're going to try and extract it out of the bottom till the spring. That was the whole plan. So this radar was going to guide the dredge on the bottom. And this is what the sonar image looks like of the plane. You can see the fuselage, the sponsons, the struts, the wheels, our cable that's hooked up to it, and that's the dredge on the bottom. And we're using that as our guide to move the dredge around.
What are the circular holes?
Those are the holes that we're dredging with the dredge. So, and the best thing would have been to have divers on the bottom jetting, but to have divers working in 200 feet of water, OSHA rules, you need a decompression chamber on board, you need mixed gas, you need this, you need that. It's impossible to get in there, impossible. So we had to come up with a sort of a remote method to do it. We only made one dive to hook up lift cables. So this was a Hawaiian diver that loved to dive deep. He wanted to do it on air, but we forced him to do it on mixed gas to keep him sane on the bottom. And this was our dive supervisor that did the complete decompression in water for him. So pretty interesting stuff. Into the hole, go do your job down there on the bottom. And there's the dredge system, which is a hydraulic jetting and high pressure water jet system. So it's sucked and jetted at the same time. Jetted to break up the sediment and sucked to remove it. The longest story of it, we spent 2 weeks out there trying to make this happen. This is the before we started dredging, and there's the after. And you can see we did get sediment off the wings area, but not enough to actually extract the plane. So the plane, unfortunately, is still there. But it was an incredible operation in attempting it. This customer still would like to get this plane if there's a plan that would work. Within reason. He's not going to spend $1 million on it, but he has spent $250,000 on it so far. So waiting for the last flight out, sitting on the ice waiting for the push planes to come in and get out of there. So you can see this sonar really, though many of us look at it as a sonar and a geophysical survey tool, to me, it's a gate that has given you the opportunity to go out and explore and discover things you never would think of. And I mean, every time you put one of these in the water somewhere in the world, you just don't know what you're going to find. That is sort of the real fun part of this. Whether you're a geologist or a shipwreck hunter, there's discoveries to be made. And since most of us can't go to the moon, we can at least go underwater to discover. And that's where all the big discoveries will be made. So anyways, we're at 4 o'clock. I didn't leave time for questions. But I'd be happy to answer any questions that anybody might have quickly.
You've seen a lot of progress in the technology of sonars. What would you like to see improved even more? You know, considering the audience that a lot of us are working on that.
You know,
technology.
honestly, sonar hardware, from a design point of view, is really mature. There are a few new places to go with it. The only place I've seen that has some potential that I was somewhat skeptical of in the beginning, just like I was skeptical of AUVs in the beginning. You know, 6, 7 years ago, I'd call them a novelty toy. You put these little things in the water and you hope they come back. You know, well, guess what? They go in the water consistently and they always come home today for the most part. The other technology in the sonar side that is sort of being developed, but it's expensive, is what's called synthetic aperture sonar. And the advantages of synthetic aperture sonar over all conventional things we do with side scan sonars is that, in theory, if it's done properly, you can achieve resolutions at long range that are unattainable by conventional means. And again, I was very skeptical of synthetic aperture sonar, but some of the recent results I've seen with it are really positive. And I think if you have that important kind of requirement that will support spending $1 million, because that's what these cost. When you get done, by the time you get done with the hardware and the software processing and all the support stuff, it's $1 million for a synthetic aperture sonar. It's not $40,000 like a conventional one. But the advantage is the range and coverage and resolution is pretty impressive. So I would say that's where, if they can make synthetic aperture at lower cost, I think there's going to be a substantial market in the general survey world. Otherwise, it'll be a novelty in the military because of the high cost. And very few commercial companies will delve into that expensive kind of sonar.
Is Klein developing anything like that?
Not synthetic aperture. Not right now. So, yes.
What do you think of the efforts to develop automated target detection for side scan?
Oh, that's an interesting topic. I'm going to give you my read on it. It's never going to happen. Not with any reliability. I mean, automatic target detection and classification has been worked on since the 70s. And it's still worked on today by everybody. And you can make software do automatic target detection and classification in controlled environments. You throw it into the real world, and 9 times out of 10, so far, it fails miserably. Every time they give you an example of automatic target detection and classification, they do it on benign bottoms, sand or mud or clay, a few targets, and that's it. Throw it into New York Harbor and show me it classifying a target. Years ago, it's more sophisticated today, but years ago, a company called Tracor developed under a defense grant an automatic target classification enhancement system. And you run that with an experienced operator, that'll fail nine times out of 10. Experienced operator will an operator has that ability to look at data and look through the noise, the distortion, the aspect, nature of targets, and to think and to make a decision, where a computer can only do what's programmed into it. It is not going to do it. So myself, I know people are working on it. There are a lot of companies that are pushing it. And again, all the examples that they show are under controlled. You can make anything do anything you want under controlled conditions. If I can throw it in New York Harbor and it can actually find me a mine or find me this target, I'll believe you. But I have not seen that today.
Speaking of mines, that's, you and I were both involved in the 80s and
Sure.
90s and that, but is the Navy still using side scan for some
Tons
mine
of it.
classification?
Yeah. Absolutely.
Again, it's mostly classification. I mean, it's interpretation.
Yeah. So anyways, that's my sort of read on it, Andy. Everybody will have their own flavor, but I don't think in my lifetime I'm gonna see a set of software that I would bet my life on to find a mine over a person. I'll take a person any day that's experienced.
Is the software good enough that it can narrow in on areas? Because
Of course, software can enhance and simplify the task. There's no question, and there are different things that, to me, the biggest thing in finding an object, there are two modes. One is classifying something. What is it? The other is detecting what's new, change detection, a new target that's been placed in there. Now, there are a lot of easy tools like transparency, swipe tools, other tools that enhance an operator to recognize a suspect target. And that's what I'd say software is really good at today, is giving you those tools to simplify the process. I mean, in the old days, it wasn't easy to say, is this a new target here or not? But today you can layer on georeference data. You can do a transparency swipe, and your eye immediately picks out any change on that. But for the software to say that's a valid target, I'm not a believer yet. I must have been born in Maine, you know, there's a joke about people from Maine.
I think, well, the human visual system is great at pattern recognition. It's one of the areas that artificial intelligence and computer vision hasn't really caught up to human vision yet.
Yeah.
I don't know. I tend to think it's going to get there.
Yeah, and again, it may. I mean, I made the comment about AUVs. I wasn't a believer 6 years ago, but I'm a believer today. And synthetic aperture sonar, a few years back, I thought it was sort of, theoretically it's great, but practically it's probably never going to get there. Well, I'm seeing results now that are saying it's really getting there. You know, so it may be, but so maybe 10 years when I come back in the wheelchair, you can say, see, Garry, I told you it was going to happen.
How do you deal with the navigational uncertainties of the fish? You know, you're looking at centimeter
Oh, you
resolution.
brought up a real interesting topic, because I've been in a lot of these accuracy of position of a target on a body. And I've just been on trials over in Italy where we're doing a towed system with USBL tracking, Hugin vehicle AUV, bluefin AUV, and amazingly, let's see, do I have this? Yeah, I do. I can probably pull this open real quick just because you asked that one question. Let's see, where did I stick it under? Here's something interesting about positioning and what we can achieve truly today. Let's see, it's probably right. Let's see if I compiled it. Just trying to find which folder. I had a folder because I just worked on this last week. Where am I at today? Positioning error. Here's a towed system with no, this is an AUV system. I'm comparing two AUV systems.
Oh.
This is multiple passes in all axes and directions and getting an error circle. What kind of error do we get on a target?
Underwater for how long? Out of contact with GPS for how long?
We have a USBL, so we know precisely where it is on the body.
Okay. No,
We know exactly the
So
geographic.
you always use USBL?
Well, when we're testing the error on a system,
Yeah.
we put a USBL on the target, so we know precisely where it is, and then we find out what is the error on the actual
Yeah.
processing when you do it. Turns out that roughly 7.3 meters was the furthest distance from the exact location of the feature. That's off of bluefin AUV we're running. And just a couple weeks ago in Italy with the Hugin vehicle, let's see, the Hugin vehicle, amazingly, let's see, where, oops, I'm clicking too quick here, I apologize. I know time is up, and I know it's probably beer time. This was on, well, this is a towed system with a USBL. The error circles were again about 6 meters.
What water
Towed
depth?
system. And the Hugin vehicle I did was 7.3 meters. So you notice we're getting a number here,
Yeah.
6 to 7 meters, with the best USBL precise positioning that you can have.
What water depth?
One was in 1,500 meters. That was a bluefin. The Hugin was in, I think, about 35 meters only. And the towed system, this one was in 55 meters. And all of these got USBL. These are not using layback algorithms or anything else like that. We're using the highest precision you can get on the market today. The number is 6 to 7 meters.
But that's USBL by itself. It's not using like a bottom tracking or any inertial system to
Well, the
help.
AUVs all use INS systems
Mhm.
with acoustic modems, with USBL updates acoustically to the INS to keep it right on. I mean, this is with the best of what you can get right now today.
I'm
The
surprised.
number is between 6 and 7 meters.
I'm surprised the number's that big.
A lot of
Especially
people
if you're
are.
35 or 50 meters. I mean, I think we operate in AUV a lot, and I think I can do a lot better than 6 to 7 meters.
Test it. Put a USBL beacon on the bottom, get the position, run axes, north, south, east, west, tabulate it, do the error circle. Let me know what you get.
Is
Okay.
that the position of the AUV or a target that it's picking up?
Target it's picking up.
And where is that in the swath? Is it?
It's in various places. I mean, you can see you've got, depending on, there's a lot of passes made in different axes, north, south, east, west.
So it didn't matter a lot whether it's really close to the net or
No.
north?
No,
So
some are right, almost under, some are up.
There's
So
always
do you
assume.
see any kind of an offset on side-to-side swaths?
Not really.
No, you don't in side scan, so why don't you? If there's that kind of uncertainty in the position. It's not just location, it's also azimuth and all kinds of.
Of course. Well, the AUVs, but the
Well, yeah,
INSs are
they're-
very
yeah,
straight.
they're good,
They're
yeah.
not
But
like a
tow
towed
the side
system.
scan.
Tow system,
Yeah.
there's uncertainty because of
Yeah.
what is the heading actually. at
But you
the
don't
moment.
really see that often unless you get right down to the weeds.
That's right. So, but the number is all ringing out to be right now 6 to 7 meters. Yeah. Anyways, I know we're way over your time. I apologize.
Any more questions? Thanks, Gary.
Well.